So, as I said, Chapter 11, this is sections 11.1 and 11.2 we are doing today. This Chapter 11 is a kind of a collection of stuff, I don't know, this is the stuff we haven't covered yet, is one way of looking at it. So this first time will be parametric equations. We're having fun with those in pre-calc. And then the next assignment will be polar equations. And the last assignment will be on vectors. And parametric and vectors will be pretty similar. But one at a time. So today, parametric. So we're going to do a quick recap of, you probably did a whole unit in pre-calc on parametric equations, and we're going to try to review that in the next 4 or 5 minutes here. If you remember, a parametric equation was where you were told what x equaled and what y equaled in relationship to another variable. Often t didn't have to be. If it was trig, it would usually be theta. This third variable is called the parameter. Exactly. Maybe you never knew that before. So a parameter is just a third variable. For example, t for time, or theta for the angle measure in radians. Okay, so those are the two most common parameters, but it could be anything, any third. So, you're going to get one. They're going to ask you to graph it. We'll show you how to graph it in calculator in a moment, but first I want to show you how to graph it by hand. So you should be able to find points, plot points by hand. So we have x, y, and t. Make a table just like you would normally, plotting points, x, y table, but of course now we have that third parameter, t, so we're going to make a column for that. Okay, and then over here, we're going to graph out on an xy axis, or coordinate plane. And you'll notice you're not going to be able to, there isn't a value for time on here. You don't have a time axis, but time is important when you make this graph. So 1, 2, 3, 1, 3, 4, -1. Alright, so just plug and chug. We take values, plug it in for time. Let's say we start with 0. So we're going to put 0 into our equations. First putting 0 in to the x equation for t, and you get 2 times 0, which is 0. And putting 0 into the y equation, you're going to get 0 plus 1, which is 1. So here's our point, the point 0, 0, comma 1. And I would graph 0, 1. There's a point right there. And they might indicate the time at this point, so you would maybe draw a little arrow and say this is when t equals 0. Because that time factor is important. Then we try another number for t, maybe 1. Plug it in, we get 2 for x. Plug it in here, square 3, you get 4 for y. And you get the point 2, 4. 2, 4 is right there. And that's when t equals 1. Now you won't have to do a ton of points, but you're going to have to investigate and be able to find where this thing is at certain time values and know how to plug that in. Can you have negative time? No. Of course you can have negative time. You're still shaking your head no. Yeah, you can have negative time. We can put -1 in for time. That would be, if this is seconds, that would be the second before time equals 0. Okay, think of it like a countdown if you want to think of it that way. So, put -1 in, we get -2. And -1 squared is still 1, 3, 4. And you get the point -2, 4. And you get t equals -1 there. And then you go through and you can plug a whole bunch of more points if you had to do it by hand, but you won't ever have to do more than a few points by hand. You would most likely just do it on your calculator. But you get the idea that you're going to get this shape in the end. It's kind of hard to tell with these 3 points, but it'll be a parabola. And you can indicate the direction this particle is traveling along this parametric equation. So this is t0 or -1. This is t0, so you know that it's going that direction according to the time. So time is an important feature to the graph. All right, questions on that? Let's grab our calculator. Let's graph something on our calculator here. So the first thing you got to do is change the mode. So we're no longer in function mode. We want to switch it to parametric mode. Right there. Now when you hit y equals, you notice that it has changed. I'm going to clear out these out of here. We're going to use that exact same example. So we're going to plug in the x equation, which was 2t. It actually does a t now instead of an x. And the y equation, which was 3t squared plus 1. Oops, that's not plus 1. Plus 1. And then I'm going to hit graph. Ugh. That's not very good. It doesn't show me. So you have to be able to change your window. I know some people aren't very good at that, but you have to think about adjustments you want to make in order to be able to see the graph that you're looking for. My guess is it probably said t minimum for you 0, and then it did 2 pi for t max. 3.28 or 6.28 or something like that. Did it do that for you? If you had something stored in previously, but if you just the first time using it, probably did that. So a lot of times when you initially go to it, it thinks, hey, we want this to be trig, something with trig. But this isn't about trig. Our t value we want to have here, I don't know, we started at -1. Let's just start at -2. And let's go to +2. And then you got a step. The step is extremely important, the t step. That is the increment that you're going to be putting in t values in. The smaller the step, the more points you're going to be putting in. The bigger the step, the fewer points you're going to be putting in. This is how you're going to slow this thing down so you can see what direction it's going. And if you get a wacky one, you know, oh, it's probably because of the step. Like if I put 1 here, that means it's going to put in -2, and then it's going to put in -1, and then it's going to put in 0, and then it's going to put 1 and 2, and then it's going to connect the dots. It's just going to go dot to dot. And look at that. That's weird. It's just like that. Okay, so we know we definitely want to do that. We want to have a step, and maybe we'll do, let's just do 0.1 for right now. X values, I want to see the left side of this parabola. I'm going to think maybe like -4. My x max +4. Y scale, it will automatically change your x scale and y scale. Y minimum, 0 is fine. I don't know what you want to do here, maybe 20, we'll see. Now hit graph. And there's my parabola. Now if that went too fast, because if I hit graph again, it just shows that same graph. If I didn't like catch what direction it was going, I can go back to my window and change my step to a smaller value to slow it down. And now I get a better idea, okay, that's the direction it's going. So the direction is important. You can also hit trace at any time, plug values in for t. I can find the t value. When t is 0, I get the 0.01. That corresponds to what we had in our graph. Do you remember doing that stuff last year in pre-calc? Kind of, maybe? That's that good? It kind of reviews the whole unit you had in, I don't know, you probably spent weeks on it in pre-calculus, but that's it. That's pretty much all you need to know. Now let's do some fun with calculus. That's all pre-calc. Let's do calculus. Well, if we're doing calculus, what are we going to be doing with calculus? Derivatives. You bet. So let's do derivatives of parametric equation. same equation we had before. And that's how it's listed out, the parametric equation. Now, just before we go too far along, so I said parametric today, polar the next assignment, and then vectors the next assignment. Well, parametric and polar are very, very similar. And sometimes they'll actually give you a parametric equation, or excuse me, parametric and vectors are very similar in terms of there's a lot of crossover. As a matter of fact, sometimes they'll give you a parametric equation and write it as a vector. So you might also see this written in your book as 2t comma 3t squared plus 1. This is a vector. This is the x component. This is the y component. You could see it written like that. So if you do, that's just what it means. X equals that, y equals that. Some math books use these triangular shaped parentheses instead. And so that's another way to indicate that it's a vector. Okay? So that's just kind of a side note. I don't know, how soon that will come up, but when we start talking about vectors, it'll be kind of the same idea. So we want to find dy dx. dy dx. When you first look at this, it's a little bit of an issue. You think, okay, what if I just take the derivative of this y equation? If I take the derivative of the y equation, what do I, not what the answer, but what would be the symbol for the derivative of the y equation? Yes, because it has a t in that. So this would be the derivative of y with respect to t. This one would be, what would the derivative of this be? dx dt. Neither one of those are the ones we want. We want dy dx, and we don't have an equation for y with x in it. So there are two different ways of going about doing this. In one method, I bet right off the bat, many of you would probably think of. What would be one way of going about trying to do this? Are you volunteering? Or you kind of, okay.
Solve each 5.
That is one method. That's probably one method people wouldn't necessarily think about. Hold on to that thought. Yep, good idea. Yeah.
Solve for t for the equation.
Perfect. So you're going to solve, which one are you going to solve for t? Right? So if we can get this, find out what t equals in terms of x, and then substitute it into the other one, now we'll have an equation that has y equals some stuff, and that stuff has an x in it. That's called eliminating the parameter. That would be one method. So the first method would be to eliminate the parameter. So we would take and solve for x, or excuse me, solve for t in the equation x equals 2t, and we get t is equal to 1/2 x, and then we would substitute into the other equation, so into y equals 3t squared plus 1. We're going to take this quantity, what t equals, and we're going to plug it in for that t. And we would have y equals 3 parentheses 1/2 x parentheses squared plus 1. And of course you would simplify that. You'd square the 1/2 and get 1/4, so you get 3/4. So y equals 3/4 x squared plus 1. We just eliminated the parameter of t. And now the derivative is easy. dy dx is just 3/2x. If they asked you to take the second derivative, the next derivative, in other words, find second derivative. So this, what would it be? 3/2. That's a piece of cake. It's easy. Why? Because that has an x in it. So we don't have to do anything special. We just keep taking the derivative. If this is the derivative we're taking respect to, if that's in there, we just do it like we normally do. We don't have to give it any thought at all.